Hello everyone, and welcome. Today we're diving deep into the story of a material so common we often take it for granted: stainless steel. Just take a moment to look around you, from the gleaming cutlery in your kitchen drawer to the sleek appliances that make modern life easier. From the surgical tools saving lives in hospitals to the towering facades of our most impressive buildings, stainless steel is everywhere. It's an unsung hero, a silent workhorse that combines beauty with incredible resilience. But have you ever truly stopped to consider how this remarkable material is created, and what makes it so special that it resists rust and corrosion, unlike almost every other metal we encounter daily? Get ready, because we're about to embark on a fascinating journey, uncovering the history, the science, and the intricate process behind the making of stainless steel. Our story begins over a century ago in the bustling, smoke-filled industrial heartland of Sheffield, England. The year is 1912, and the world is rapidly advancing. In this era, a brilliant metallurgist named Harry Brearley was hard at work. His mission, however, wasn't to invent a rust-proof metal. Instead, he was tasked with solving a very specific problem for a local arms manufacturer: gun barrels. The intense heat, friction, and corrosive gases from firing were causing gun barrels to erode and wear out far too quickly. Brearley, a meticulous and innovative scientist, began experimenting with various steel alloys. He was adding different elements to his steel mixtures, hoping to create a metal that could withstand these extreme conditions. One day, amidst his discarded samples, pieces he had deemed failures and tossed onto the scrap heap, he noticed something truly extraordinary. While most of the metal pieces were covered in familiar reddish-brown rust, one particular sample remained remarkably bright and shiny. It was an accidental discovery, a serendipitous moment that quite literally changed the world. What was the secret behind this seemingly magical piece of metal? Harry Brearley had added a significant amount of chromium to his iron, specifically around 12.8%. And here lies the true genius of stainless steel. When chromium comes into contact with oxygen in the air, it doesn't rust in the traditional sense. Instead, it forms an incredibly thin, invisible, and highly stable layer of chromium oxide on the steel surface. This remarkable layer is often referred to as the passivation layer. Think of it as a self-healing microscopic shield. If the surface is scratched or damaged, the chromium in the steel quickly reacts with oxygen again to reform this protective barrier, constantly renewing its defense against corrosion. This is precisely why stainless steel doesn't rust like regular steel, which forms flaky, destructive iron oxides when exposed to moisture and air. So, how do we go from raw materials to the gleaming, durable stainless steel products we rely on today? The modern manufacturing process is a testament to human ingenuity, blending centuries-old metallurgical techniques with cutting-edge technology and precise control. It all begins with the careful selection of raw materials. These include iron ore, various types of steel scrap, often recycled stainless steel itself, and crucial alloying elements such as chromium, nickel, molybdenum, and sometimes titanium or manganese. Each of these elements plays a vital role in determining the final properties and grade of the stainless steel. These carefully measured ingredients are first loaded into a giant electric arc furnace, or EAF. Imagine a colossal cauldron where temperatures can soar to over 3,000 degrees Fahrenheit, hot enough to melt even the toughest metals. Powerful electric arcs generate this intense heat, transforming the solid metals into a molten, glowing liquid. This initial melting process typically takes between 8 and 12 hours, creating a base metal mixture that is far from its final refined state. Once melted, the liquid metal isn't quite stainless steel yet. It's filled with impurities, most notably carbon, which, if left unchecked, would prevent the formation of that crucial passivation layer. This brings us to the next critical step, refining. One of the most common and effective refining methods is called argon-oxygen decarburation, or AOD. In the AOD converter, gases like argon and oxygen are injected into the molten metal. The oxygen reacts with the carbon, burning it off as carbon monoxide gas, while the argon helps to stir the mixture and remove other unwanted elements like sulfur. This process is absolutely essential for achieving the low carbon content required for true stainless properties and for fine-tuning the chemical composition to exact specifications. This refining stage is also where the steel is precisely tuned by adding specific alloying elements. For instance, adding nickel enhances ductility and formability, making the steel easier to work with. Molybdenum is often added to improve corrosion resistance, particularly against pitting and crevice corrosion, which is why it's crucial for marine-grade stainless steel. Depending on the desired properties and the specific application, other elements like titanium, copper, or nitrogen might be introduced, each contributing unique characteristics to the final product. This precise control over the chemical composition allows for the creation of hundreds of different grades of stainless steel, each tailored for a specific purpose. Once the molten metal has the perfect composition, it's time to give it a solid form. This is achieved through casting, where the liquid steel is poured into molds. This creates large solid shapes known as slabs, blooms, or billets. Think of these as the giant building blocks of stainless steel, ready to be transformed into various products. These solid forms then undergo a series of shaping processes, primarily rolling. First comes hot rolling, where the steel is reheated to extremely high temperatures and then passed through massive rollers. This process reduces its thickness, refines its internal grain structure, and gives it a rough shape. For even greater precision, strength, and smoother surface finish, the steel might then undergo cold rolling. This process is performed at room temperature, further reducing the thickness and imparting superior surface quality and mechanical properties. After all that intense shaping, the steel needs a little relaxation. It undergoes annealing, a crucial heat treatment process. The steel is heated to a specific temperature and then slowly cooled. This process relieves any internal stresses that built up during rolling, making the metal more workable, less brittle, and restoring its ductility. Following annealing, the steel often has a layer of scale, a dark oxidized surface from the high temperatures. This scale is removed during descaling, typically by immersing the steel in an acid bath, a process known as pickling. This step cleans the surface and prepares it for its final appearance. Finally, the stainless steel gets its signature look and feel through various finishing processes. This can involve polishing, grinding, brushing, or even specialized treatments to achieve different textures and lusters. From a matte, brushed finish commonly seen on kitchen appliances to a highly reflective mirror-like polish used for decorative architectural elements, the possibilities are vast. Each finish not only contributes to the aesthetic appeal, but can also influence the material's performance, such as its resistance to staining or ease of cleaning. And there you have it, the incredible multi-stage journey of stainless steel. From an accidental observation by Harry Brearley in a Sheffield laboratory to the intricate high-tech manufacturing plants of today, it's a story of innovation, precision, and continuous improvement. Stainless steel is more than just a metal. It's a testament to human ingenuity, a blend of scientific understanding and practical application that has profoundly shaped our modern world. Next time you encounter that familiar, enduring gleam, whether it's on your watch, your car, or a piece of kitchen equipment, take a moment to appreciate the complex history and the intricate process that gives stainless steel its unique, indispensable qualities. It's a material that truly embodies durability, hygiene, and innovation, making our lives safer, cleaner, and more efficient. What other everyday materials do you want to know more about? Let us know in the comments below. We love exploring the hidden stories behind the things that make our world work. Thank you for watching, and we'll see you next time.